Welcome to another TA Tech Tip. In this tech tip, we will discuss how to complete a monotonic tensile test using the Apex 1 and use that information to start a fatigue test. The Apex 1 is made for mechanical testing of materials and components. The Apex 1 can execute a wide range of mechanical tests due to its frictionless design and large 100mm stroke. This unique ability is well suited to perform monotonic and dynamic fatigue tests in a single instrument. Electronically adjust the crosshead so that you have enough stroke for your samples. To set up your upper clamp for a dog bone sample, turn on the mover power in wind test and move the upper clamp using the preset. This can also be adjusted using the adjust mover under the instrument setup tab. Insert your dog bone sample, then tighten your lower and upper clamps. Under Test Setup, click Monotonic. In Test Parameters, click Pretest. Set up your preload and dwell time. In this case, I will set my control sample to a load with a value of 1 Newton. Click on Test Prompt. Set your control channel to DISP for displacement. Next, set your rate according to your method. Failure detection should be set to enabled. Use normal stiffness mode for everything but extremely soft or stiff samples. These are the default settings. Under post-test, set your axial to stop, which will hold the motor in position at the end of the test. Power off can also be selected. In data storage, optimize is the typical setting and requires no operator input as the software automatically calculates the appropriate data acquisition rates for your test parameters. You can go to advanced settings to adjust which signals are recorded and the data acquisition rate if you desire. In the file name box, type in your desired file name. Click on the Specimen Setup tab and click on the specimen information. Input your specimen dimensions in the space provided. Make sure your direction is in tension for a tensile test. Click Run and Start to begin your tensile test. In Trios, a live stress strain curve will start. Sample break will be detected by the instrument and the motor will automatically stop. The motor will then move according to your post-test setup. Once the test is complete, select the analysis method you desire from the drop-down in the Intelligent Analysis box. In this experiment, I will select ASTM D638. Click Execute to analyze your stress strain curve. The linear region is automatically selected here according to ASTM E3076. Because it is a polymeric material, we have defined the yield point as the local maximum. Different pre-programmed analysis methods and materials have the option to change these settings. Modulus measurement can be defined in a variety of ways according to your material type and standard practice. After removing the broken sample, press Preset. This will move your upper clamp to the correct position. Insert your dog bone sample. Then tighten your upper and lower clamps. Under the Test Setup tab, click Cyclic. In the Control Channel box, select Load in the drop-down. In the Cyclic Parameters box, select Sine and input your desired load values in level 1 and 2 boxes. These values will be based on previous tensile tests. In this case, we will enter 490 newtons and 49 newtons. This is 95% of the ultimate tensile strength with an R value of 0.1 for a tension-tension fatigue test. Next, input your frequency. In this demonstration, we are using a frequency of 5 Hz. Cycles should be set to the desired stop point. If you are running to failure, set this to a higher value than you expect your failure cycle count. I will set this to 100,000 cycles. This cycle count is used to calculate data display parameters, so a much higher value than expected is not recommended. Failure detection and stiffness mode should remain the same. In data storage, input your desired file name and select the Optimize. When selecting Optimize, the software will automatically calculate the data rate and ensure that the expected file size is within allowance. Click Run and start to begin your fatigue test. The peak-valley data will be displayed in trios. This view shows a reduced number of points compared to the data being recorded. If you right-click on the last data point, you can stamp the point where the sample broke. By clicking the experimental section, a data reduction method and file type can be developed according to your needs. In this tech tip, we discuss how to complete a monotonic tensile test using the Apex one, and use that information to complete a fatigue test. Please stay tuned for more helpful TA tech tips, and thank you for your interest.